Yeah, so we are moving on to the day 6 session 1. So before start of the session, let me remind once again, today being the last day, we have the online test and the overall feedback. Participants, please kindly complete the formalities for mandatory issuing of the certificates. So without much delay, let me invite Basil sir for introducing the speaker.
So good morning, one and all. Myself Basil, faculty member of Mechanical Engineering Department, Vishwadi College of Engineering. Today is last day of the Sttp Phase 2. We have the guest, Dr. Vijay Rajeshwaran sir. He is the Managing Director of VA Microsystems Private Limited. And about his academics, he completed the bachelor's degree in Electronics and Telecommunication from Madurai University. And he's done his master's in Communication Systems from Madurai University. He also completed the PhD in the field of power electronics and drives from Annamalai University. He has 4-year experience as a scientist at Central Electronics Engineering Research Institute, CSIR, Government of India, Madras. And he has also the 5-year experience as manager, Prakriti Computers, Pondicherry. He promoted the company VA Microsystems Private Limited, Chennai in the year 1986. And he is the chairman of ITA Antipati, and he is a syllabus committee member in few institutes. About his research areas, he published many papers in international journals. He co-authored a book, A Practical Approach to DSP. I welcome you, sir, for handling this section.
Thank you. I'll share my screen, sir.
Yes, sir.
Okay. It's visible, sir?
Yes, sir, it is.
Yeah. I thank you, sir, for giving this opportunity for taking the participant in what is happening in IoT, what is this IoT, where is the applications, what is the importance of this one, this IoT. And it is a nice topic, that is IoT-based manufacturing and design. So it is actually leads to smart manufacturing and our industry 4.0. If you see the automation in industry, one side is a core automation. That is, you have your PLC that is processing. Then you put you have input output sensor and actuators, and PLC controls all the machines. Suppose you have it will be powered by induction motor, which is been powered by VFD, variable frequency drive, which is connected to your PLC. The PLC gives a command to speed everything. And there is the PLC talks to SCADA, or it goes to a DCS software. That is a traditional way of doing it. Now we want to become more smart. So this PCS7 the DCS or SCADA is connected to MES. That is a manufacturing engineering system. That in turn connected to ERP. So ERP will get an order and everything, will process and will pass on to MES. MES will do the lot of processing, will become intelligent system to do that. And parallelly, we see the right side, you have a infrastructure, you have a industry 4.0 where the sensor actuators are connected, and it is going to be analytic, and it is put into the cloud. So parallelly, the two things are happening here. So for if you do a milk manufacturing like Avin in Tamil Nadu, so for packaging everything, you don't need more sensors. Then you need a minimum sensors to operate or to produce. So you can put more sensor like vibration sensor in your conveyor belt, your camera. You can put a lot of other things. That's what the right side is. Then the data will go to the cloud for analysis. Supposing one particular plant, the milk is gone to Trivandrum, milk pipe. So somebody makes a complaint, they can trace at which point, what time, and what is the health of the machine, and who is the operator, and at what condition, what temperature. All this can be analyzed and further can be rectified. That is a smart manufacturing or industry 4.0, and which is assisted by in the IoT. So that's a very good system. So this manufacturing, all the manufacturers are moving towards smart manufacturing. Industry 4.0, IoT. So IoT connected equipments. All the equipments will be connected, like what we are connected now, internet. So now Internet of Things. So everything is going to be connected to the cloud. So that's the internet. So that is what is IoT. And MES become more and more important because it enables real-time unification of electronics and mechanical production. If you have a lathe, that's going to be connected to the cloud through the sensors and everything. So that is what the MES, this one. And MES manufacturing execution system. IoT is not all part of that. That is why I'm talking about that. And monitor, synchronize the execution of a real-time physical process involved in transforming raw materials to finished goods. For example, ITC, that makes many commercial products now, food products. It's all automated. So that is all synchronized and it goes to the cloud, empowering a lot of things. So a lot of analytic works. And it is in the MES got a lot of advantages: real-time production analytics, ability to integrate other systems like PLM. PLM, you have NX, so many softwares are now there, ERP, other MONs, and quality of production. So many advantages there in MES is that people are moving to that. If you see any industry, it is a conveyor belt, a lot of machines, a lot of equipment, robo, everything is there. And over that, you can, this motor, there is an induction motor to drive the your conveyor belt. So you see that there are it's all powered by a vector control VFD. So this has got a lot of this is the latest one. I just bought recently. So I just want to share this. It has got a built-in intelligent PLC. You need a separate PLC. Now it has got an intelligent PLC inside, and it has got many industrial buses. You have RS-232, 4-20 mm. All are going away because IoT needs because that's going to be more than 50 billion devices going to be connected to the cloud. So industry also that the thousands of sensors going to be connected to the cloud. So that time, if you want to transmit RS-232, it's going to be 9,600, about maximum of 1 Mbps. Even Modbus is 1 Mbps. That's not sufficient. So what is happening? Industry Ethernet bus. So that has become very. I'm talking about that about 4 or 5 years. Now it is going to become in the syllabus. I think that Tyagaraja College we are going to form a syllabus on this industrial Ethernet bus. The Ethernet has become more standard. Everywhere people start using that, and it is more robust. But it is not real time. So a lot of consortium they made a individual. They took the Ethernet and they made it real time. They had a little more on the stack. So they called individual group called as a individual protocols. So one is called Ethernet CAT, another one is a Profinet, Circos. There are about 6-7 industrial Ethernet bus. So we call it as a time sensitive protocol or the sensitive networking also. It's going to go up to 2.0 gigabytes also. The people are working ABB, Siemens, everybody is working on that time sensitive networking in industry. That is this Profinet, everything comes under that. And this device has got a models, separate models to convert that to the Profinet or the EtherCAT and everything. So this now to drive this, you need this vector control and induction motor. Over that, if you fix intelligent condition monitoring system, this is a small artificial intelligence enabled embedded system or IoT node, sensor node. It captures all the vibration, sound, current, and electromagnetic transmission. That you have, it takes about 5 parameters and predict. So all these are happening in the industry now, connecting everything. So this is not needed for the production, but you parallelly you are doing it and connecting to the cloud because of the to monitor the health of the machine, and they can tell. No, that's why I told you when it is packaging the milk when there is a fail. So this can tell you what is the current it has taken, the induction motor, what vibration, what is the electromagnetic, All these parameters which will decide tomorrow you can avoid that. The manufacturing can avoid, they'll spoil the name. Okay, why I'm talking all these things? That what way it's relevant to me. I started my career as a scientist. So in the first one, I started with the embedded trainer, the 8085 trainer. That's what I was, that, 78. There is not much development in the embedded system. There's only 8085. So my first project was a small project, that is 8085 trainer. That is what that put me in the started the company maker system, catering for the education. So the main project was condition monitoring system. So it is basically a FFT analyzer. We want to do it in a rotating machine. We want to put that time, I think, BNK. We want to be indigenous BNK equipment in the country. So that is FFT analyzer, 2 channels FFT analyzer. And I did it. There are 2 groups, only ISRO and myself is working. So I did it over 78. This one now it is matured. Now it's that time there's no microprocessor, there's no embedded system, there's no DSP processor. I implemented through a bit slice processor, port slice processors and everything. Then I did a lot of other industrial projects. Then I moved to Pragati Computers. That is another common for IoT, that is cloud computing. So I worked on, I believe, 5 years on the research and the manufacturing of computers. Started with ISR80, then we went to 8085, 8086, 8088, 8086, then went to 286. Then that was, then we moved to 68000, 6010, 2020. My final project was 6020 based Unix, porting Unix under that, making about 32 terminals. That is a base. Unix-based system is the base for the virtualization and the cloud computing now. That I'll cover a little later. So with this, then we did a lot of sensor networking, everything. About 10 years back, we got a sensor networking based on a Zigbee and everything in VMX system. So that has now become a IoT. So internet connected things. So in embedded system, you have microcontroller, microprocessor, then become a microcontroller, then we become embedded controller, then become a SoC. All these developments happen. So with that all my experience, this is what I'm sharing with you. So this is relevant to me. That is what I was just trying to emphasize. And if you see the in the impact of IoT in manufacturing and everything, I'll go a little more deep into the IoT because that's what the base of that, and remaining things only the applications. And if you see that now recent newspaper, there is advertisement on a smart watch, which measures a lot of your parameter, your body parameter, measures body temperature, heart monitor, and your exercise mode. Whatever you are doing, they're trying to put it into the capture it through a smartphone and put it in the computer. Why I'm talking about this is one of the important. We see the monitoring SPOS2, then monitoring the body temperature, monitoring real-time heart monitoring, check blood pressure, and your Apple computer can do the blood pressure, blood oxygen levels and everything. And this has got a lot of impact in our day-to-day life now. Now, if you go to the hospital, they take a lot of your samples of blood, X-rays. So after that, it's all After that, they do the result. That is a diagnostic type. In future, because Siemens has got this major player on the scanner, full body scanner and PET scanner, everything. So it's about $500 billion business they are doing it. They separated it because of this IoT is going to kill them. They predict. I don't know. Tomorrow, all your data, all your body temperature, everything is going to be into the cloud. With the artificial intelligence, they can predict when you're going to have a heart attack, when you're going to have some serious disease. So in the driver is driving, sometimes you see a drivers that driving have a heart attack, that is accident and everything. So this is all going to save that this one they can tell when you're going to have a heart attack and everything. So then what is the need of all the scanners, everything? So this it will solve. So the cloud computing and the artificial intelligence, IoT, is going to redefine our life. So that is why this is one of the big application of IoT. Condition monitoring system. This is one very, I wanted to release it about 2 years back, but I think it's a Israel company's list this product, condition intelligent monitoring system for any rotating missions. In all the industries, they are all rotating missions with the artificial intelligence at the edge. There's a lot of solution now in there in the artificial. Many people are giving a solution for artificial intelligence. It can port into the Cortex M4 processors. So that will be in the front end. That is a node, a sensor node. So it is based on a ADMC 4050, which is from analog devices. So it has got a sensors and everything put together. So it is a small machine. Fix it into the machine, into any rotating machines, and it is a monitor vibrations, magnetic field, temperature, sound. In sound also, sound it's also it is one of the way to detect what is the machine's problem. So current within very fast, and in a processing in any industry, you can fix that on the machines. It'll tell you what is the health of the, I mean, like in oven milk, when it is packaging. These machines will be all rotating machines will be there. So where then you can understand which batch, which time it is, and defective because of this IoT enabled. And now in the house, that is, you will see the house automation. IoT is going to play a major role. The IoT enabled BLDC motors based ceiling fan has come already. A lot of advertisement now has come. One of the companies giving that. And IoT based trip education, your house farm in the backyard or in the your terrace, you can have a IoT based trip education. And you have a your AC has become IoT enabled, your fridge has become IoT enabled, your washing machine become IoT enabled. So everything, all they're giving us a package now. So your house completely can become completely IoT enabled now, and it is scalable now. This IoT, if you want to spend time, nothing everywhere, we are putting a lot of energy into the IoT, and you have also done this 5 days course on the IoT because it is the number of nodes, number of things are connected is keep on growing. I think right now it is 2020, it's about 50 billion. And every year, I think they're going to put billions of devices going to be connected. And so it is a worth to go inside. It has got, and demand for IoT is also increasing, whether it is a secured or insecure nodes, IoT nodes is going to be also increasing. It's all in the research publications. And data generated in because of the IoT in USA it is about 32%. In Western Europe it is about 19%. In China is also 13%. In India it is only 4%. There's a lot of scope. I think we are just starting. China and all, there's got a big consortium for IoT. They're investing about $500 billion or something like that. But here we have started in Bangalore. I don't know what is the status of that. There is a consortium that started in Bangalore in IAC, I think, but there is not much news about that. But it's a big thing. I think we have to concentrate more on this. So it is worth a lot of opportunity for all of us, for all the, and it's a multidisciplinary also. This IoT is not only for mechanical, it is electronics, it is civil, it is computer science, and everybody is playing role on that. So it is giving a lot of opportunity for education, for engineers to, for the industries. I forgot to tell you what this industry 4.0. Okay, I have experience right now. Along with Siemens, we are working with 3 industries. One at Madurai, another one is Seat Tire in Chennai, another company in Bangalore. We are putting Siemens is putting complete industry 4.0 with MES software, with DCS, with the Technomatics, a lot of other softwares they have. So I am working, my team around 5 people are working in Madurai to make it as a digital twin. Before you execute anything, we want to do everything in simulation. They have a lot of software like Comas, they have a Technomatics, all these softwares are put together. They can completely digitize, you can completely have a digital model of a industry. So I'll also show you that how it is going to be working. So this is because of that, it is very essential for us to go deep into that. And you see the L&D recently has got a contract for 5 million smart meters house. It all going to be fixed in the house. So it is in the UPN bigger. They are taking the contract for 50 lakhs smart meters going to be fixed. And I think Kerala, I think they have an advertisement and everything. And I think every state is going to be fixed with that because it's going to be give a lot of data analytics for the concerned people. This work involves meter installation, data storage on the cloud, and preparing dashboard and data analytics. So this will tell which part of the country is less power consumption, where it is more. All this information will be very useful for the government to plan. So this is why every house is going to be a smart meter. But another advantage or another thing is, I think the solar power generations keep on reducing. I think 5 kilowatt you can get it for very cheaper now, 2.5 lakhs. I think it will come down. And capacity of the your solar panel, I think previously we had about 100 watts. Now we have about 325 watts. So it's going to keep on increasing. With 3 models, you can have about 1 kilowatts. So the space is also very less. Otherwise, in the space also, you can occupies a huge space. So it is going to be a power generation also going to happen in your house. 1 kilowatt, 2 kilowatts power generation. Whereas the wind is also there. That's going to be another good advantage. So you need a intelligent smart meters to control or to monitor both bidirectional power flows. Applications everywhere now: transportation, healthcare, smart environment, personal, wherever it is medical. All these are big applications, and healthcare, transportation, and smart home. I think all the houses is going to be smart tomorrow because it's going to save a lot of time. So, for example, you are going back to our house, so you want, if it is IoT connected AC, then you can program that. Okay, you work when I come, the AC should work at 22 degree. The heater should be on. The fridge should be on. It should be something you can do that, and you can make the coffee maker. You can make it on. So all this can automatically you can program from your smartphone whatever you want in the house. Even your smartphone will be the key for opening your house also. And why? Then the IoT, it is a very simple. No? We are going to connect a sensor to a cloud, to a computer through a gateway. So what is the big things? That is not a big things at all. But because there's a lot of things. If in the house you're going to connect it to a IoT, open it, then what is the problem? There are 2 things. One is the security, another one is availability. When it is you want to open the house, it should be your data, everything should be available. So the availability and security, that is the big things. So that is why we are paying huge money for that. The cloud computing, for everything you're paying good. And the Siemens has got a MindSphere cloud, which they charge almost 5 lakhs for a 2 user. So it's very expensive because of the availability and because of the security. So if somebody your house should be secured. So that is because the 2 things, it has been very costly. Like a PLC, normally the PLC has got a 8 digital input, 8 digital output, unlock input, 2 unlock input. For that they charge about 40,000 rupees. If it is a 4 on Cortex M4, it is only 2,000 rupees, 1,500 rupees. Why it is? Oh, okay. It is not audible, sir. Hello.
We can hear, sir, no problem.
Oh, no problem. Somebody is saying internet is not stable. So that when you talk to the PLC, it is a less features, but why the people are charging 40,000 because of the reliability for the industry. It has to work 24/7 by 365 days. And if the same thing, it goes into the military, they'll be 10 times costlier than that. And the same thing for the IoT. It should be reliable, it should be robust, it has to be available. So that is why we are talking about this in a big way. And it is in a smart industry. That's what it is there. Everywhere it is, all these are connected. Slowly it is happening. We done it in Madurai. Now it's slowly moving to see it tire company in Chennai. I think the government of India is heavily on smart city. So they're converting everything into the automation or smart and electricity metering. This is another metering. You can see, you're going to be seeing in all your houses. And our point of sales, whenever you go for a purchase, all the purchase will be connected to the IoT now through your smartwatch. So that will give you a lot of time taken. Some defect is something's defect, you can talk to them or you can do rectify it immediately. So there are a lot of advantages for that. And your logistics now, the logistics is very interesting now. We send some industrial wise, we are sending some parcel to African countries, or you are getting some consignment from USA or China. We will know where it is because it is all connected by a RFID. Through RFID, we are connected to the cloud. So that way it is now we can trace your parcel anywhere. That's because of the IoT. Now nobody is calling anybody. Now just go to the computer, log on that, and it is there where it is available. It is immediately known. It's because of the IoT enabled. And people are investing a lot of money into the agriculture, like smart agriculture. You see, the Bosch has got a lot of developing, a lot of sensors. And we see that the slide will give you a little more in depth of how the IoT is implemented. A lot of sensors have been connected to the plant and everything. And temperature, like humidity, all these sensors connected through a gateway. The gateway is an embedded system with which will work 24 into 5, 7, and 360 without any fan, and goes to the cloud server that will be the database with artificial intelligence, with the deep learning, everything. It will give a service to the through your smartphone or a computer. So when to harvest, when to watering, all this could happen intelligently. So this is growing in a very big way. So we also implement IoT-based machine learning. So that is for the industry. I keep talking about that. So you have a number of in the lathe, milling machines, so many special machines. Everything is available there. You can see roboting, and it's all rotating. Everything. It's all rotating machines, and doing a lot of automation in the industry. And you are going to continuously monitoring the assets integrity. We can, what particular point we are taking a sample of. It's one of the industrial output I technique. Sampling rate is about 100 milliseconds. A number of variables 98. Main variables are machine rate, cycle time, tool number, and we are taking it sample for 3 months. And data stream size is about 50 megabytes per hour. And we are doing that. We are monitoring the condition monitoring also, our spindle bearing condition, tool clamping, ball screw, servo motor temperatures and torques, and consumption of energy, electrical energy, coolant, cooling water, all this compressed air. All these are monitored. This is one of the waveform. From there, it's taken. It is a current waveform taken from one of the machines. If we look at that, the first slot, it is only a half, and the second slot is double, and third is wrong. It is not expected like that. Found because of the IoT, it is in the cloud, it is there. They found out that there's a CNC code programming is wrong. Then they rectified that. This is one of the practical implementation of IoT. And there's a lot of books also, a lot of, by the academic people, we need a lot of books. So there is a book, Industrial Application of Machine Learning. So it's, it talks about a lot of industrial automation and everything. So it is the details of that book. And so it is worth to go deep into that. IoT-based Industry 4.0, industrial IoT, or for discrete process industry. There are two industries. There is a discrete is making cars, and that is a discrete. Process is your power plant, pharmaceutical, continuous process happening. Both is and more complex. Process industry is more complex. Industrial IoT, as I told you, there is a digital twin can be implemented before you erect the industry. So this all used, the software used as SCADA, DCS, SIMIT, COMAS, Technomatics, PlanSite, MES, all these softwares are used for to create a digital twin. And it's all IoT enabled. All sensor can be simulated in softwares like Simulate. You can simulate the sensors, all the sensors, and so you can. So we call it as a digital twin of that. So there is a 3D modeling also available in this one, like the plant site. There's another software, and you can see the this is a simulation. In the simulation, all the sensors are connected, so you can run it. So you can make it running and everything. So you can see, you can monitor what is the sensor output and everything. And this is another model of that. This is a real machines, and I'll just show you one of the implementation which you have done. This is a VRC machine in one of the, they make V-belt, timing belt for the car in JK Funner. That is a Funner company in Madurai. So we have done that, the digital twin of that. Everything done in a simulation. I'll just show you that. Yeah, this is a one machine. There's no voice, but I am going to talk to you about that. This is a mission of making. We put about 25 belt. You could see, yeah.
So you cannot able to see the video, sir.
1 second. Okay. 1 second. I think it's gone. How is it, sir? Now it's coming?
No, sir. I think you can share the entire screen and then show the video.
This usually will come. Is it you're able to see, sir? No.
No, sir.
Okay.
Stop sharing and then share the screen.
Got a problem. One second. It is usually come. No, I tested in the morning. It's coming. Okay. So I'll try once again, sir. Now my screen is available. There's shown.
Yes, sir.
The morning I checked, everything is okay. Now once again I'll try. It is visible, sir?
No, sir. Again, the PPT only you can able to see.
Okay, I don't know whether I can do that completely.
So if you have the video separately, means you can play it separately, sir, not from the PPT.
Yeah, separately, okay, that is possible. I'll just see that.
Just stop sharing and then share the entire screen of your laptop.
What I done. Now it's visible, sir? No.
No, sir.
Okay, I don't know. This it's going to be very interesting. So this VRC machine, what we did is, I don't know why it is not showing. What we did is we created the machine and the NX. We designed that. Then we through the NX MCD, that is NX is a CAD/CAM software. So that has got a lot of options now. They added a lot of Siemens added a lot of add-ons. So one of the add-ons is the MCD, that is the Mechatronics Concept Designer. And submit. So this machine basically is dumb. You cannot do anything. So if you added MCD, you can add sensors and everything. So now it is a real machine. Once you added your sensors, everything, then you can use. They have a software called PLC sim that you can simulate a PLC. So now you have simulated a machine which is with the sensor, everything. You can simulate a PLC. So you can write software, everything in a simulation mode. Then you can make it working also. So all these all in SCADA, and you can write a program in SCADA, HMI, everything. That is what we are trying to demonstrate. I don't know why it is not working. So I'll try to show you in the end of my talk also. So we'll show you real time now how the sense of temperature is working, how the sense of distance is working, what is the cooling period, what is all these are this VRC machine. So that's a digital twin. We do everything say simulation through IoT, and the IoT also enable that. A lot of IoT things are started coming. IoT chats. Now, if you go to any fair, we have to give our name, visiting card. All these are now the Corona period. We don't touch anybody. So this is it is built into the chat. It comes with the chip. So it will give you a LinkedIn profile, Facebook, and visiting card. So this is going to be another company. It's called Ralph. They got a much more intelligent system which will measure your real-time biometric data, heart rate, calories band. So all your data is going to be, put it into the cloud for a predictive analysis. So streaming the information to the iPhone through iPhone or Android phone, everything is going to be there. So you have IoT enabled bag. So we have when you are an international traveler, this plays a major role because you should know what your weight of that. Otherwise, they'll say they'll not check in. So you have to remove your set. That you can see the scenery in when you are checking into the international airport. So location tracker, battery charger, remote locking everything is become automatic. This one IoT enabled. And the smart vending machines. You have a vending machines are there now everywhere. Vending machine. It is US. It is everything is a vending machine. Whenever you want to buy, there's no shop. You have to go to vending machine. But like in here also, it's already in the mall. Everything is coming in. It is a Microsoft Azure. That is a cloud-based service. Your hardware is locked down to your cloud. From there, you can repair. You can do supporting. Now you can update your software, everything. And this has become more smarter now. The advantage of this vending machine connected to the cloud is smart stocking control. Yeah, we can definitely have a camera to monitor whether it's you can recognize whether it's a teenagers are using more or old people are using more or the children are using more. Depends on that. You can stock whatever even you want to stock. If Pepsi is the more liked by a teenager, you can put more Pepsi or Coca-Cola or whatever they want. So it's called a smart stocking. Automatically it can happen. Smart hardware maintenance, smart target marketing, smart interactions, and smart payment options. All these are the advantages of IoT. And this another good example is petrol bank. Petrol bank is a lot of robbery can happen. So or it not being no quality is if the quality is not there, nobody is going to come. So all these can be monitored. Consumption, petrols, and building everything can be completely IoT enabled. So the owner manager can monitor completely operation, the quality of operation of this fuel petrol pump. Your house completely now going to be IoT enabled because everybody is IoT, Samsung, everybody is IoT enabled. So for example, IoT, this IoT enabled, the number of eggs is around 20, maximum egg. If it is reduced to 5, then you suppose you have forgotten, you will not get your food. So you can, if it is IoT enabled, you automatically log on to a supermarket or any mall. So they will automatically come and fill it, or they'll deliver the excess egg for that. So that is advantage of IoT enabled fridges. And the Samsung equipped with the new ACs. All the ACs now coming with the inverters. So inverters means they need automatically a inverter controller will be inside. So inverter controller is now you can make it IoT enabled where you add Wi-Fi or you add any wireless technology, it will be connected to the IoT automatically. So you can control the AC through IoT. So it has already come. A lot of advertisement is that IoT enabled, IoT is come already. And voice control, so many things now you can do with that. And if you see in industries, a lot of pressure compressors, a lot of power generators, all the rotating machines, all can be. The right side, the left side is the compressor. The right side we have put shown here Siemens IoT 2040, that is a gateway. To that we are connected to the IoT server, that is IoT cloud services. So it will monitor all the, like if we fix that intelligent condition monitoring system, we take all the informations from these compressors and the power generator, put it in the cloud. So we know, so when the cloud can advise when to repair, when to do that, all the information will be noted. Especially in the power generator, if you into the apartments, if you have a cloud connectivity, I think though they are doing it in Chennai. I've seen a lot of places. If some theft is there, the watchman can remove the petrol. So that we know it is connected to the cloud. The cloud immediately can alarm the concerned people. There is a problem with the power generation is not there. somebody is removing the petrol. So that all is the advantage of this IoT. And they can predict when that's going to fail. Then they're also in the send the service in a correct time. So when power generation is down, so the industries, it's become very problem. So it can be smartly maintained. And this is one of the implementation we are doing it to now another college, one jet set and everything. We are putting the ICOMARKS condition monitoring system. We put the IoT 2040. There's one other place we are proposing that we may implement this with this. This is smart distribution of power using utility power and genset. And we are putting a lot of condition monitoring system also. You can predict when this is going to fail, or it'll give you information, everything. And we are putting a lot of intelligent power contractors, everything. So fully managing this. It'll be in the cloud, so any department can manage that. So one of the project we have done is we have put this Siemens 2040 in compartments, in a railway compartments. It will measure, it will monitor, and all the parameters like temperature, vibration, everything. It will inform to the cloud. Cloud can predict, or it can analyze what is the problem of the compartment. It will inform to the concerned authority. And we one of the college, we made a complete automation. I mean, partly we have started doing something with the RO plant. We are completely IoT enabled, and a sewage plant we are completely enabled that. And through IoT 2040, there are about a few gateways from Siemens. That is, one is the IoT 2020. It is meant for students. 2040 is for industry. 2050 is a very powerful one, which I'll talk about a little later. And this is the implementation which we have done that. And plant watering also, we have done it through IoT. So this is the implementation of that. I'll not go deep into that. I just want to show you that. And a roof garden, that's going to come in a very big way in everywhere because of the IoT. So automatically can watering and everything is going to happen. So we have done it through with Arduino. This is a controller. We monitored two places. The soil humidity on the soil moisture, and automatically it will watering that. So that's much more involved. It's not only this. We put a trip education also, all the controls or everything, and somebody has to involve in that. Otherwise, it will not work out. So, but automation can be done through IoT, and this government of India. ITA is one of the entering part of our education system. So we're trying to make a lot of technicians on IoT for smart agriculture. There is a 2 years course has been started for smart agriculture, IoT based, and IoT technician smart city, and IoT technician smart healthcare. I think last year onwards they started offering. Many ITAs taken it up. They're coming in a very big way. So already informed that the course content also very good. A lot of practicals, a lot of this one they're exposing to all the wireless technology, cloud computing, everything. So it has been, I think, because of the IoT importance, this has been introduced. And we can define, which is we are talking. Internet of Things is, in short, extending the power of internet beyond computers and smartphones. Now the smartphones are connected to internet, and computers are connected. So we want to connect it to everything, the process and environments, and the ability to transfer data over a network without human to human or human to computer interactions. Automatically happens. Automatically, the artificial intelligence will take over that, and that's a lot of automations. One of the good example is automated with a driverless car. Driverless car means we are going to put a lot of sensors connected to the cloud, and through 5G. I think the 5G will be the 1 gigabits per second that transfer it. So availability and security can be easily implemented. So the car could be completely controlled by the cloud. So there is another example of that. And what is this? What is this IoT architecture? The IoT architecture is basically you have a sensors, microcontroller with the built-in RF. So there are many RFs for your application. So Wi-Fi, a very high fast rate, you can have a 500 Mbps or 1 giga, so the Mbps transfer rate. Whereas your Zigbee is another wireless technology, which will give only 500 kilobits per second. Whereas you have a LoRaWAN, which can give more than 20 kilometers coverage, whereas transfer rate will be very low. Then the security, which I am talking about all the way. So there's security and availability. That is another component of the IoT. The next one is connectivity. Gateway connectivity. So all this, there'll be hundreds or thousands or 1 million sensor nodes will be available for your one of the applications. All going to be routed through a gateway to the cloud. So that is a system which you have. You go further down, I think this will be more relevant to the electronics people. So you have a embedded controller with the ADC DAC. You have a sensors and actuators. Then you put a software, write your own software controlling everything. Then go to the gateway that goes to the cloud. The data will go to the cloud where the people can analyze the data history, data analytics can happen, give the correct information to the end users. This is another form of that. You have the device hardware, device software, communications, cloud platform, and cloud applications. And this is a basic IoT device. So if you go to the further down of implementation, you have microcontroller, RF transceivers, then you have internal sensor, you have actuators, power supply, everything together. And this is one of the implementations. This is our one of the trainer. This is a temperature sensor connected with the Zigbee. So you have the top board is RF board, that is a Zigbee board. It is basically based on a microcontroller and RF also built into that. Then plus you have a ADC for unlock sensors. Then you have a I2C, SPA, all this about digital sensor. The bottom one is the battery board. And then we have a lot of connectors to connect your sensors. You connect to the sensor. This is a sensor node. Whether it is a Zigbee or Wi-Fi, this will be almost same. We made it bigger because for the training the students, we can be make it very, very as small as possible, as compact, and make it ruggedized. That will be a commercial model. And this is this model is based on a CC2538. That is one of the IC microcontroller. It is a Cortex M3 based. You know, the most of the embedded controller used for IoT needs a low power. It is more achieved through Cortex series of ARM processors. You know, Cortex M series. So they have M0, M3, M4, M33 is going on, but M3, M4 all used for IoT implementation. It takes very, very less current than 8051, the older 8-bit versions. So if you see this, this has got a RF transceiver built into that. So it's more reliable. Everything is single solutions, more reliable, more robust and everything. So it has got a Cortex M3, then RF transceiver, then IO connectors. So when you go to the implementations of all the sensors, if you see the bottom on all the sensors, the center point is IoT 2040, that is the gateway. And this has got a sorted one. It has got a Zigbee, it has got a Wi-Fi, then it has got a Modbus, then it has got a LoRaWAN. And this particular gateway has got a Profinet bus. I already introduced it. It's an industrial Ethernet bus. Most of the PLC, most of the DCS components, all will have a Profinet. It will be based on a Profinet. So you can directly connect it to the processing, DCS or a PLC. So the PLC will do the real-time actuations and everything. But this is all the data, everything captured can be connected to the cloud. So this will be the industrial implementation. That's what we are doing it in the industry in Madurai. So we are using many 2040 and everything to the mission. They collect all the information to the cloud and be integrated with the MES. And if you see that, this is actual implementations. So we have a cluster of sensors. Bluetooth also now previously traditionally used for replacing a short wire. Now it is being used for everywhere. So now this, especially for IoT, that is also play a major role. So we have Bluetooth-based sensors. There's a cluster of nodes. Then Wi-Fi-based cluster nodes. Could be millions. No, I'm just talking about very small. Zigbee, we can go up to 65,000 nodes in one cluster. The RFID, there is another play. Then LoRaWAN. All these are connected to gateway. The gateway later connected to the in turn connected to the cloud. So this is the structure of any IoT. This is basically what we are doing in digitization. So what IoT 20, so industry 4.0 or smart manufacturing or IoT, all this is basically what it is doing in digitization. So already in your life, in our day-to-day life, a lot of digitization has been done. Your bookstores completely became completely converted to the computer. Now I don't think You can buy books, but you can always download and start reading it. That's called e-books. Your yellow pages, about 5-6 years back, in every house will have yellow pages where you have to refer your names and everything. They're all gone, completely gone. It is completely digitized. Your songs, your video, all the completely digitized now. The movies are now recently released. Movies are through Prime Movie. All this through internet only. So taxis now there's no more calling the taxi and everything. You just call Ola, and it'll give you complete information when it is coming, where it is coming. Your Google Map, it moves everything now. So it is an advantage of in an airport, especially you book, it knows where it is coming and everything. So that is a big advantage of digitization. And the industries, if you look at these industries, the left side is the media and trade and mobility. It is all less complexity. It's already digitized. If you go move towards health, discrete and process industry, and energy, the more complex. So slowly they are digitizing, but they're using digital twin and actual implementations. So more complication is already happening now. They're converting. And if you see the your automation, no, your manufacturing plants. So you have this is a you will see the PLC that is controlling your robotic, all your rotating machines that happen in real time. Parallelly, in the information is going to cloud. That is this is an example of Industry 4.0 implementation through special protocols called MQTT and OPC through OPC, anything can be connected. Suppose I have a Siemens SCADA or ABB SCADA. I want to connect ABB PLC to my SCADA or Siemens this one or Delta. Through OPC, you can connect anything now. So it's all become a universal one. So a lot of things happening because of the IoT. And okay, if you go to the chip, what is that chip related? I'm more interested in the chip of that. So this is one of the chip list from NX. You see the very intelligent, it's all released for IoT implementations. This one, if you see the right side, it gives you a real-time the Ethernet, industrial Ethernet bus like Ethernet IP, EtherCAT, CIRCAS, Profinet, CAN, Modbus IP. All these are 100 Mbps buses connected to the various sensors. Like I told you in the first itself, VFT, that is called a Profinet. You can directly connect, program it. It's become very simple now. So in the bottom one, you got a CAN, UART, I2C, ADC, and you can connect discrete and sensors to that. The left side is, it offers you MQTT, MQP, and OPC. This is meant for a cloud connection. So parallelly happens. So this is this side for controlling all the equipments and everything. Left side is your cloud connections. There's another chip from another German company. It's also having the same thing. It's called a NetX 90. It's got 2 ARM processors, so you can implement all the protocols of that and connect. It gives you ADC DAC, so it can be connected to that. So, and this IoT, so it is it is assorted different applications. So covering the wide variety of usage, it's a lot of issues are there, and the various environments like agriculture, healthcare, and serving diverse requirements. In healthcare, it is the accuracy, everything has to be very, very high. I agree it's needed, but in healthcare, much more. Otherwise, there'll be casualties. So definitely IoT for healthcare should be much more robust and everything. And serving diverse requirements. No single wireless standard can adequate for IoT. So a lot of things are happening. The IoT, about 2-3 years back, simple connections, but now it is going in a much faster rate because once wireless, the LoRaWAN has been introduced a few years back. Previously, wireless, they got a Zigbee and they got a Wi-Fi only. Now there's got a LoRaWAN that is getting more popular. And I think people are working on new protocols, new wireless technologies for taking advantage of IoT developments. And numerous wireless technology standards are deployed in the market, spreading over multiple frequencies, different communication protocols. So this is a partial a list of the wireless technology available for you to implement IoT. This Zigbee, Bluetooth. Bluetooth is also getting very, very popular. Once previously only Zigbee is always offering mesh networking. Now Bluetooth is also offering mesh networking. Wi-Fi also offering mesh networking. This will be very essential for in the houses if you are going to implement IoT. So it is a normal one. If it is one path is cut, then you will lose your connectivity. In a mesh networking, it will take another routing. So that is what the advantage of mesh networking. So you have WiMAX, then RFID, GSM, GPS, and with the introduction of a lot of new technologies, this GSM is going to be very, very popular there. In GPS and LoRaWAN. And this table gives you a comparison of what are the technologies. You can choose, depends on your application, you can choose whatever you want from this. So we are trying to implement one of the project we are taking was monitoring about 350 kilometers of pipeline. So where you have to put IoT and monitor at various places, around 100 places, or every 5 kilometers, we need to put the instrumentations there through IoT or declared. So we are finding out how to do that. So we are using a Bluetooth, we are using a Wi-Fi, then we are using a GSM also. Both three technology we are using to completely do that. Then what are these components which already introduced, but once again we'll redefine components of IoT. There's sensors for different applications and wireless control, wireless boards to connect sensors to your gateway, Zigbee based wireless sensor boards, Wi-Fi based sensor boards, then Bluetooth based sensor boards, powerful gateway and cloud computing, and then comes the big data analysis. That is a commonness of that. That's what the structure of the IoT which we want to implement. So if you see that, this gives a implementation of that. The left side, the bottom side, we have a embedded controller. It's called PHASE-2. It has got a 2-core, that is a Cortex M4 and Cortex M0. So if you can implement a watch, smart watch, you can do it much more application. It has got a Bluetooth built into that. So for Bluetooth based application, you can just really a good choice. This is a really interesting chip. So this is the front end. We call it as a sensor node. So we call it the embedded controller with the sensors and Wi-Fi and RFID. You can add a Wi-Fi also to that through another model. So Wi-Fi or Bluetooth goes connected to the IoT gateway. So that everybody is making gateway. You go to the HP site, there will be gateways. If you go to ASUS, there is a gateways. So it is definitely has a big importance. Siemens make a industrial gateways also. I mean, they have a gateway. So this is a Siemens gateway. Through a router, you go to the internet. The internet is connected to the cloud computing. Yeah, cloud computers, you must be knowing. So you have a form of or a cluster of servers, high-end servers like 20 core, 30 cores, 40 cores, or much more than that. One each blade server. So there will be thousands of blades of server will be there. All these are virtualized, and they create a VMs. The VMs can be logged onto IP. So from remote place, I can log. So that's what I think. We are trying to, this whole system is logged onto the IP to one of the virtual machines. So you can have a one of the virtual machine will give you all the solutions. So you can log onto that. You can just this. There is a cloud computing. You put all your application, all your development tools there, and you're going to monitor all this data is going to be stored there. And your storage also will be virtualized. Your communication also virtualized, everything. So that way, the cloud computing is going to offer you availability, security, then scalability. Supposing in some ensemble applications, you want a 2-core instead of 2-core, 4-core, immediately can be offered. Within a fraction of a second, they can offer you. Suddenly, you want more RAMs, about instead of 2 gigabytes, you want 8 gigabytes can be offered. But in a normal traditional computer, that's not possible. You have to physically add everything. But here it is a scalable everything. So this is the implementation of a IoT, this one. So I'm just showing the once again the sensor board, and there are many sensors. We have to talk about sensor. That is the big one of the main thing of component of IoT. So everybody, a lot of manufacturers are fighting to take a big spot. TE, connectivity, STMicroelectronics, TI. So one of the few, but a lot of manufacturers are keep on introducing many sensors for IoT applications. This is a hollow bed sensors, and you have light sensors. Then you have accelerometers. Then automotive sensors are many, because you are going to have another few years. You are going to see another, already is there. Already test drives are there. You can buy 100,000 pounds. You can buy a automated car, driverless car. You can buy. So it's going to be a driverless car. So many sensors going to be put there. So many the sensors plus so many embedded controllers been developed. Intel has made one vision sensors. TA has got a one vision sensor. You can monitor about 8 to 10 cameras at a time, can visually process the data, edge detection, all these things. When the car goes in the road, you can detect everything. So that's so much intelligent. It has to do it faster, and it should be connected to 5G. That's why the 5G is going to major role on that. So all these are very challenging. People are working on that. So many sensors as input. So humidity sensor, so many sensors, microphones, MEMS microphone, pressure sensors. MEMS pressure sensor huge. If you see that Honeywell, they are making marvelously many sensors have been put for IoT applications. And LoRaWAN based smart meter. This is a water meter with a LoRaWAN fixed into that. I think this has been ordered by Delhi authorities about 7.5 lakhs pieces. So your house is going to be completely smart water with the water supply. Our water supply is smart. You'll have this one. You can even disconnect everything, billing, everything. So like a smart meter, electricity meter, this is going to be a smart water meter. There's going to be more advantages. Record. I think it's done by Itron, of French company. That's been done here. This is another company which just got a Wi-Fi connectivity. This one. So all these are making IoT is much more simplified. And a lot of sensors has come now. I think this is from BRC. So you have a ECG machine. There are many sensors in the thing. This is one of the ECG machine. You can see it in everything in this one. The advantage is once it is in the cloud, so you can be viewed by any specialist doctors. If suppose some special doctors that are there in US, you have your send this using this, you can capture your ECG, you can send it to him, he can give advice where is the problem and everything. So all this makes it much more easy in the IoT medical services, much more easier. And for the agriculture, that is another big this happening. This is one of the solenoid valve, which is for opening and closing your valve for water flowing. So this is very ruggedized. No, this is very interesting. I've seen that it is really good. Many research has gone. There's robust, and thing must be made of plastic, of the special plastics. So it has become good, and it takes about 140 milliampere at 24 volts. So it is very, very low power devices for this kind of IoT applications. And we have many embedded controllers for this kind of applications. TA, everybody is coming. TA, unlock devices, everybody is calling a lot of this. This is one of the chip. It is called CC3220 with the Zigbee and Bluetooth and Wi-Fi built into that. So it is another device. This recently, ST Microelectronics released a chip. They call it a 32M GW or something, which has got a Bluetooth and Zigbee. So many applications are built on Bluetooth and Zigbee for IoT application, for machines and everything. So this is from LoRaWAN. This is our LoRaWAN model from Microchip, and the another SoC from Cypress has been released, powerful low power IoT Cortex M4 based SoC for sensor and wireless integrations. This is a PSOC 6 with it's got a Cortex M4, Cortex M0 plus. It has got a BLE, that is a Bluetooth 5.0 is built into that. The many components, everything is there. No, for any kind of application you can build. You want to build a scanner for this one, you can build. You can have a watch, you can build. This got a very good dual core CPU, so you have a very good high power computing power. You have a connectivity, so software defined peripherals. So you want to build a smart watch for data processing, for security, or so connected to internet. This can be a very good device. And many apartments, they'll have a doorbell, video doorbell. The quality of doorbell video has to improve, and it will be connected to the IoT. So the artificial intelligence will tell you who is coming, who is at the now, because the crime rate is very, very high in the cities. So this kind of IoT enabled solutions will be really a boom for the people. So another component is a gateway. So gateway is made by everybody, Intel, Dell, all the manufacturers. This is one of the gateway based on Atom. So there is a computer, no? You can put your Windows 7 or whatever operating system you want. This is based on a dual core with ruggedization. It is certified by Microsoft, Azure, IBM, Bluemix, all these cloud supporters. And it has got all the peripherals, HDMI, USB, and one of the good thing is aluminum housing with the industrial grade. So it will work 24/7 into 365 days without any fan. So that is a catch in that. So this another Dell is making a gateway. It is based on a Intel Atom 2-core or 4-core. It support Windows operating system. Memory, what sort of memory you want, you can choose. Then in the interfaces, serial interfaces, whatever you want, you can choose. And wireless, this one, wireless, you want to choose. Software, or the software certification also available. And this implementation of that. And this is another gateway, which is manufactured in another industry in Europe. It is specifically meant for industrial. So it has got many features, which I'll not go deep into that. And you have a Profinet, Profibus center. Whereas the Dell Gateway, it is not that. This is a addition for that. You have a Profinet, Profibus, SmartBus, Siemens someone you can connect directly to that. Then database management. So everything is out. This all used in one of the some industries. It's a direct connection with the MES ERP systems. And this is the Smatic IoT 2000. It is from Siemens. They have a 2020, then they have a 2040, then 2050 is very recently released. So 2040 is very interesting. 2020 is meant for students, costing about 10,000 rupees. 2040 is meant for, it is for industry. It is actually, they are taken from Intel. Galileo board taken, it's open source Galileo board they taken. They added a Profinet, they added more, and then they ruggedize it, went for industry. Industry will not use everything, they have to be ruggedized, supported by people and everything, like the ABB or Siemens, that should be supported. There's got a 1 GB RAM and everything. It is a Yocta Linux, there's open source. You can put a Python, you can put a C++, for developing software, application software, you can develop using Python, C++, Java. So for the students, it's going to be a great boom. Only the hardware has to be get remaining thing, everything is open source softwares. Then this is a manufacturer of motherboard. It's called Supermicro. They also make gateways because it's a big market. So they are just doing that. So I have the gateway. This is based on i3 7th generation. Now I think now it have gone to 11th generation also will be available. But all the interfaces like COM port, USB, digital display port, all are available. So that for that, whatever application you want, you can build on that. And the Unlock Device is one of the big company making devices, ICs. They had a solution for IoT. So what they done, they make a lot of MEMS sensors, microcontrollers, everything like that. And the iMOX, which I was talking about, condition monitoring system based on Unlock Devices components. So you can put, they have accelerometers. You can put all these equipments under your heading, under your rotating machines, and you can cloud-based operations. So it will predict when it's going to fail. That is from Unlock Devices. And they also had a agreement with New England, a lot of farmers, small farmers in England. They tied up with Unlock Devices for developing IoT-based farming, tomato farmings, for fast harvest and sustained growth of tomatoes. So they basically design a lot of sensors and connectivity through gateway. It is going to the cloud. The cloud services will analyze and give you the farmers when to harvest and what watering. This improved their productivity. So in India, it's very less happening, but I think it will improve after this. All these courses will make the farmers confident to implement IoT-based agriculture. So this is basically meant for faster harvest, sustained growth of tomatoes. And these sensors are measuring is shape, sugar, aroma, acid, humidity. And so all this will go to the cloud, and with artificial intelligence, will advise the farmers for the better harvest. And we have many IoT solutions, and for a basic understanding for the students to the industrial ruggedized IoT applications. We are doing it in some places. We are doing based on IoT 2040. Now the IoT 2050 is a really great advantages for that. I'll just explain what is IoT 2050. And we are providing end-to-end solution like sensors, embedded board, wireless topology, gateways, cloud server, hardware, big data, analytics softwares, everything giving in the full journey. For industrial internet development laboratory, we are giving many gateways. That is, the Raspberry Pi is used as one of the gateway for the experimental purpose, for the laboratory purpose. IoT 2020 for the students, 2040 is for industrial gateway. with the 7-inch touchscreen LCD. And there is a Beagle board, like a Raspberry Pi. The Beagle board is available. That is AM335. So it's a very interesting board. You can use it for image processing and everything. And that also, yeah, that is mostly, there are a lot of industries are using that. And there is another gateway released by DA in the Beagle board that is called AM5729 with the artificial intelligence. This is a very interesting chip. As I told you, that thing would have been designed for a automatic car, but it is very useful for our implementing many IoT applications because it has got a 2 ARM8 processors, ARM15, 2 DSP processor, 2 Cortex M4 processor. It has got a PRU that is called real-time processing unit. That is meant for industrial Ethernet implementations. And your DSP processor, if you can add any camera to this, you can add a lot of image processing and everything. Very well suited for the waste management in a municipality, in a corporation. Wastewater management is a big thing. It is runs into crores. So this chip we are also giving a proposal to in Madras. This based on this 5729. Various parameters, various features can be implemented like image processing, weighting, and recognizing the people who is collecting that. All this can be, now they come and take a photographs and send it to their boss. But this is there, it will completely into the cloud and completely automate a sewage clearing system. Then sensor nodes, we are making a lot of sensor nodes available, Arduino based. Everybody is, even ST Microelectronics, Cypress, everybody is targeting sensor nodes, their own embedded controllers. Then the embedded controllers with a lot of features into that, with the SoC, with the sensors, so many things, features into that connecting. So that become advantages for our implementing sensor nodes for our own application, or our applications. Many sensors we are offering. So basic sensors, there's RH sensors, light sensors, everything we are offering along with that. And special sensors, a lot of sensors we are offering. Advanced sensors like ICOMAX, then Omron based environment sensors for water quality, for outdoor air quality. So all this can be for weather measurement, weather monitoring systems. All these can be as advanced sensor codes you can offer. And our implementation is this. We are taking Raspberry Pi is one of the gateway. IoT 2020 or 2040 or 2050 is another gateway. Then Black Beagle board is another gateway, because this got a lot of you can program that the students can write their own program, and it's not ready-made. No, it has to be open to the students. Then a lot of cluster of sensor nodes for each gateway. So we have put a cluster of Zigbee, Wi-Fi, then Bluetooth, all these clusters we have put. We have made as boards and everything available to you. Then you can connect to through a router to the cloud. You can have two types of cloud servers. One is a remote, wherein the scalability, everything will be there. Or you can build your own entry-level servers. So for experimentation, you can put your own software, you can put your own application software, you can do that, you can test it. So that will become a full-fledged laboratory of Internet of Things. And this is the expansion of that. This is based on a AM3358, and this is based on a Raspberry Pi. This is based on a 2040. These are the details of the sensors. This is based on a Zigbee sensor node. I will not go deep into that. So, and this one, slightly, I want to expand this. This Zigbee sensor node, as per the mechanical engineering, we want to only take the data and give it to through the gateway. You want to connect it to the cloud. But as far as the electrical and the ECE people, ECE students, they can download the stack. It's openly available to this microcontroller through this debugger. So we are offering a debugger. Along with that, we are offering a AR compiler for that. So through this, the stack can be modified. So now we want to implement star topology. Then all these nodes, suppose you have about 6 to 10 nodes, you can connect it together as a star topology or a mesh topology or bus topology. Any topology you can solve. That means you have to program, you have to change the stack. So the student can change the stack here. They can modify it to meshnet topology. It's very interesting. We are offering about 25 experiments along with that. Watching that. Then if you have then suppose you are connecting only one sensor, you have to change the stack. If you want to connect 2, 3 and everything, then you want to do a lot of additional features. You have to, the student is capable of this. It should be provision should be there to change the stack, so that you are able to do it with this model. We are doing it for long years. So this is very useful for for the basics people, engineering, EC students and everything. In other computer students, they're going to use that result, whereas the EC student, they're going to study the completely in the protocols, everything. So like the same thing with the Bluetooth, we have another sensor node. So these are features of that. Then we have another, this is from ST Microelectronics. They are based on 32, ST32 L series. That is basically a Cortex M4 with less manpower, less power consumption, sorry. It has got 5 sensors. Then it has got a 3 to 4 wireless topology, Wi-Fi, Zigbee, and then Bluetooth. All these topologies available with that. So this can be used as very well as a IoT node. Then the MEMS microphone. All these are available with this. So like that, there are many manufacturers doing it also. These are the sensors models which you are offering for this kind of this one. Many sensors we are offering. And the gateways, we are offering the gateways Raspberry Pi, the details of Raspberry Pi gateway, then AM335X, then 2020. This meant for students, they can play and the students can buy it and it's rugged. So the difference between Raspberry may work or not work anytime class, but this is not like that. It will work 24/7 days, and development software is free. It's details of that. I'll not go deep into that. And 2040 is a very interesting one. So you can connect to the PCS SCADA, you can connect it to the so many things. So much development is happening with this kind of this one. Another one latest, very recently released by 2050. There's this based on a TA processor. It's called a AM6548. It has got a 4-core A53 Cortex A53. That's what there in the Raspberry Pi also. It has got a more capacity of RAM. It has got Arduino compatibility. Then it has got a number of digital inputs and everything. And it has got a Profibus. It has got a Profinet. That is advantage, and a lot of other Ethernet interface also. It has got a serial interface, graphical interface, and so it is a really wonderful processor. It is very recently released. It is going to be. I think I expect there are many artificial intelligence. Everything is going to be ported there. It's going to be a very good base for learning. And I think 2040, more than 1 lakh pieces have been imported into the country, used for many applications. So this or the same thing will happen here also, because Siemens has got a cloud services called MindSphere. This can, if you buy this, you can directly connect to that. You don't need to write programs, extra everything. You connect your all the sensors to this gateway. The gateway automatically be connected to the cloud. So this is another advantage of this is a structure of that. Now I already told you about that. Could be 2040 or 2050 or 2020. So anything, all these sensor or nodes are connected to that. That could be connected to the cloud. Parallelly, you can connect to the DCS system or a SCADA system or a PLC system. So now finally, the cloud server. Now this final component is cloud server. So when you using IoT, I think I told you one of the implementation in a machine is a 50 megabytes of data. It's going to come out every hour. So that means you need more storage. You need more computing facilities. So you cannot handle by a servers in our servers. The private servers will not be cannot handle continuous data. It has to be there in the cloud. So it is better to migrate to the cloud. So data centers capacity is increasing. Now, if you see the articles, I think I have seen another article. It's going to be about $47 billion of money is going to be sink into the setup data centers in India. So this right now, whatever current is there within 2025, it is going to be triple because of the IoT applications. So there are 3 kinds of cloud. One is a private cloud, public cloud, and hybrid cloud. So private cloud, you set up your own data center in your college, and public cloud is so many people are offering. NetMagic in Chennai, Tata, in I think India government has made it a point that our data centers should be in India. So they are setting up everybody, Microsoft setting up. It is a big business, and we can get an offer. I got an offer for one single cloud VM for a 2-core for a 512 2 GB RAM for around 5,000 to 6,000. With all the other services, they're charging about 10,000 rupees per month. So that can be scalable. That could be a very good demo for your IoT applications. It is meant for real-time data capture, visualization, data analytics, decision makings, and decision device management. Everybody is offering you this. Google is offering you. If you just want the cloud serving, this one, everybody will call you. Google will call you, AWS will call you. So many people will call you. IBM people will call you. They give you services, both infrastructure and service also they give you. So this is IBM, the Amazon, the NetMagic. It's what I've taken. It's about 12,000 rupees for a fixed plan of large unique system with 4 CPU with 8 GB RAM with 200 GB hard disk and Ubuntu OS. So you have a IP address, so you can log on to that. This is over 12,000 rupees they are offering, and it is to that computer. If you keep on putting your data, then it become a big data. Then you have to analyze. Then your people, your students or the data analytic people can analyze the cloud's data, can give it to the end users. So we expect now when the currently about 16.3 zettabyte of data per year it is coming. Now it is going to be increased by tenfold. So because of so many devices, no volumes of data are put through many devices, and the data are coming. So it become volumes of data. So this data too large, too complex, too short-lived, it is too unstructured to be processed with regular types of computing. And the data center looks like this. If you go into the data center, you'll see like this computer center, and the data will be analyzed. The data is going to come from the IoT sensor. Could be your digital camera, your photos, audio, video, web data, mobile phones, Netflix. Everywhere in the data is going to come. So it's going to be really huge data. So this big data plays an important role. Scientists use this data to examine climate. So your recent cyclone is completely well predicted because of these techniques. So your climate, earthquakes, epidemic, and the government agencies like CBA and police can comb this huge data volumes for terrorist activities. They're going to keep on watching everything. So your WhatsApp, everything is can be monitored by this cloud service. The present data used to forecast the future. This is the cloud. So in the cloud computing, finally you want to set up a cloud computers. So it's going to be based on i5 or i7 or i9. Traditionally, they do it with the Xeon. If you go to the data center or you want to make any industries are buying, they're based on a Xeon. But for our purpose, you can based on i5, i7, i9 because virtualization technology is enabled on all these devices. Previously, only Xeon processor is going to do that. That is meant for Xeon building and servers. Now you can do it with the i5, i7, i9 also for your laboratory purpose. We look at the various processors like i5 or i7, i9 or Xeon processor. The number of cores are increasing. That is what the advantage for the establishing a cloud server for cloud applications. This i5, this particular one, 8,600 has got a number of cores is 6, number of threads is 6. I mean, with a very high frequency, 3.6 gigahertz and everything. When I built in 1983, it's 80 base 4 megahertz with 64 kilobytes of RAM. Now, number of cores, now 32-bit, 64-bit, gigahertz is about 3.6, and that time the cost is very, very high. Now, with the same cost, we are getting it in a much more facilities. And keep on going to grow. So now the i7 has got 8 core. The i9 has got a 8 core, the 16 thread, and the Xeon processor. This particular processor has got a number of cores is 28, number of thread is about 56. Another processor is number of cores is it has got a Platinum 9282. It has got a 2.6 gigahertz speed and 56 core. It keeps on improving. They keep on improving that this one. I think if you open it today or tomorrow, if you today we'll have a 1 core. Tomorrow, if you open it the Intel site, there will be a number of cores. It's a new processor. I think now they have a 11th generation process going on now. So this particular one is a Platinum. A number of Depends on your application, depends on your cost, you can choose. That is why you have a varieties of processor available for you to build your cloud server. This particular one, Platinum 8180, has got a number of cores 28, number of thread is 56, number of socket you can support. In the motherboard, usually in your traditional motherboard, you'll have one socket or two socket. In a server, there'll be two socket, but you can go, this particular one can go up to 8 socket. So it has got approximately 30 core. So if you put 8, there'll be in one motherboard itself, you can have a 240. I think Microsoft Windows 10 can support about 256 cores in one particular. So it depends on, because of this, your software, application software can be very, very much faster. Especially NX and everything can take advantage of number of cores and number of threads. So this another particular processor. It is 6512. It has got a gold series. It has got a 22 cores, and thread is about 44. Number of socket is only 4 in this one. It supports. Cost will be definitely cheaper. This one particular one is silver 4116 processor. Number of cores is 12. Number of socket is 2. Number of thread is 24. So the operation speed is 2.1 gigahertz. And bronze is another processor. And so to entry level, if you want to, for your lab, you want to set up a entry level IoT server, we call this as a cloud server trainer. There's a new processor, Xeon E2288G processor, with the open source virtualization with SQL, Hadoop, all these are open source for you, free. So you can be based on a 2288. It's a 8-core processor. They come out with the Intel, and everybody has come, Intel, ASUS has come out with their motherboard, which can be which is a single socket, and it can give you many features on that with the latest one. Based on a 2 processor, you can have there are 2 processors they are put. And the number of processors out of the 2 processor in the E series is very useful for us. One is 2236. There is a 6-core processor, 3.4 gigahertz, and number of thread is 12. So with many features built into that. Another one is a 2288. So which just gives you 3.7 gigahertz. Number of cores is 8 in one socket. And you can build a entry level server using either a 6-core or 8-core. About 32 GB RAM, 2 terabyte of hard disk, and there are 2 Ethernet ports, socket 1. I think you can build it almost 1 lakh or about 95,000 or something like that. So this could be a very good entry level for you, and or you can go for a ready-made server built from HP or Dell. Everything. So this one particular one is the ML350 Gen 8 server. It is based on Intel E5 2420. It has got 22 cores and 2 sockets, so 42 core processor. Number of RAM you can choose from 8 GB to 64 GB or 128. It's only cost is going to increase. So this is available in the market. You can buy. So we bought for a Madurai, one of the factory. We bought ML350 with advanced features. We got a 4 socket, and the number of cores is almost 40 cores, and then terabytes. So much we implemented MES and Technomatics. Then we have put SCADA into that. So many softwares we have put into that. So we are building a digital twin and Industry 4.0. We started with Madurai industry. You're going to move to Metas, and then you're going to move to so many places. So we see a big thing's going to happen in Industry 4.0 for a smart manufacturing. And then parallelly, there's a digital twin also happening. So you create, before you implement, before you touch the, so it is an existing machine, you're going to convert to Industry 4.0, that is IoT enables. So we do everything in simulations. So we digitize, we create one more model for NX. We add all the sensors, you see the performance. Then we can implement. It's become very easy. Otherwise, when you go to straight away go into the machines without any digital twin of that, it's going to be much tough. So you want to make it more smarter manufacturing. All these processes are very much needed, and this is a full structure of that. This is what in any industry will have that. You'll have that. This is the structure of that. Is the implementation of that. So with that, I think I'll stop that. Any question is there, I'll answer. And that video, I don't know whether I can play, because usually it will play, but I don't know where it's played. So I'll send it my content through Suresh. So you can take it, you can play there itself. Yeah.
Thank you, sir. Thank you very much. Any queries from the participant side?
This is a multidiscipline, nothing mechanical, electrical, ECE. So
Even participants are also from multidisciplinaries.
okay, very good. We used to run 1 or 2 courses. That time we used to face a lot of problems. So if we going to talk more on Yocta Linux, which is one component of the IoT 24 IoT, so it'll be boring for mechanical people. We're more talking about sensors and mechanical NX. It'll be but it is a multi-design, so everybody has to know that. So I think you are putting in the curriculum also. We are putting more IoT, more multidiscipline also into the curriculums. So it's going to be interesting.
Okay, sir. Because of the time limitation, we can stop here.
Okay.
If at all any queries comes, I will just collect it and mail to you.
Okay, sir. Okay, sir. Thank you.
Okay, sir. Thank you very much for the wonderful session, sir. So let me invite Arun Kesa for the vote of thanks.
Thank you, sir. Thank you, Dr. Vijayarajan, sir. The session was very informative. Basically, the IoT-based industry 4.0, various products, brands, features. The session was very informative, sir. So, any faculty interested in research area, and if they want certain products or if they require certain features, all the products you have listed, that was very beneficial. Of all participants were benefited. Thank you, sir. Thank you for the wonderful session. Thank you, sir. On behalf of this, thank you, sir.
Thanks for the opportunity. Thank you. I hope it is useful to everybody.
Sure.
So I can leave, sir, now. I can.
Yes, sir. Thank you, sir.